Let's look at example 5. This is an example of a system of linear inequalities in two variables. And so we're going to start off by just graphing each of these lines, but if we graph just the lines, we need some way to differentiate which one's which. So personally, I like to use colors. I'm going to use blue for my first one and red for my second. Now, if you don't have colored pencils to work with, or you don't have a pencil and a pen or something like that, then maybe you could label them as 1 and 2, and then make sure to label your lines appropriately as well once you graph them. You want some way to be able to look back and say which one was which. So I'm going back to my blue line. If I graph this as a line, ignoring the fact that it says less than, then I have a y-intercept of 2 and a slope of 3. That slope of 3 says to go up 3 over 1, up 3 over 1, or to go down 3 left 1, down 3 left 1. Oops, 1, 2, 3, there we go. And down 3 left 1 again, and maybe one more time. Now this one had just less than, not or equal to, so this one better be a dotted line. So I'm going to use a dotted line to connect my dots. And I'm not going to worry about the shading yet. We'll get to the shading in a minute. Let's go ahead and graph our red line. That one had a y-intercept of 1 and a slope of -2, meaning I go up 2 left 1, up 2 left 1, or I can go down 2 right 1, down 2 right 1. Now this one does have an or equal to in it, so we're going to do a solid line for this one. So I'm going to do my best job of doing a solid line that's pretty straight, I hope. It's got a little wiggle to it. That's okay. So now we're going to talk about shading. So now that I have these two lines, I basically have an X on my paper. And yeah, it's a little bit skewed, but that's okay. Basically, one of these quadrants is going to be my final answer. So maybe my final answer is going to be this top one here. Maybe my final answer is going to be off to the right over here. Maybe the final answer is going to be in the bottom. Maybe it's off to the left. So that's kind of what I'm trying to figure out, is which of those is the final answer. So what we're going to do to figure that out is we're going to go to my blue line, and I'm going to look back at the original inequality, and I'm going to test the origin. And I'm going to figure out whether the origin should be shaded or not. I get 0 is less than 2, which is true. Now don't follow along with my shading here. I just want to help you understand what's going on. What this tells us is that the origin should be shaded. So if the blue line were my only problem, again, don't shade here, this is what's going on. This is what would be shaded as far as the blue is concerned. Now, the reason I don't want to do this is I don't want to have a whole bunch of shading all over my paper and then try to say, oh, the part of the overlap is this part over here that I have to shade even darker. So instead of shading all of this in, what I want to do is I want to say this chunk and this chunk are shaded by the blue. And I'm not actually going to shade that, is I'm just going to say those two chunks are what's shaded by the blue. And then I'm going to do the same thing for the red. I'm going to come back to my original red inequality, and I'm going to test the origin on it. And I'm going to get that 0 is greater than or equal to 1, which is a false statement, meaning on the red one, I do not want to shade the origin. So that means on the red, and again, do not actually shade right here. This is just for your visual during this lecture. The red one is shading everything that does not have the origin on this side. So if we look back to what we'd kind of called the original X, the original cross of my red and my blue line, what's shaded here are those two chunks. So this kind of shows us where the red would be shaded and where the blue would be shaded. My final answer to this problem is where both are shaded at. So if we look at where we have a blue mark and a red mark, it's off to the right over here. So this is the actual answer to the problem, is the stuff that's off to the right. And that's our final shading for our final answer of where we have both blue and red. Now, one thing I didn't address here, I sort of touched on it throughout the lecture, but I just want to take a minute to talk about it, is what if we have a line that crosses through the origin? So the boundary line actually crosses through the origin. Well, we can't use the origin as our test point. Just use a different point. Pick 3, 0, or 2, 0, or 5, 7. Pick some other order pair as your test point, and then just determine, is that shaded or is it not? Based on that, which side should be shaded? So that's all that's going on here. We used the origin as our test point because it wasn't on any of our lines. But if you happen to have a line where the origin is on the line, just use a different test point. That's all.